Hello everyone, so we are going to start aldehyde, ketones and carboxylic acid chapter today. This is MSc Elementary Solutions. We'll be talking about the section A, that is method of preparation. We'll be talking about first 10 questions. We'll be discussing the solutions of first 10 questions. So question number 1 is predict which of the following compounds will have the lower boiling point than 1-butanol. So you have to understand we have 4 options here: 1-butanol, 2-butanol, 1-butene and butanoic acid. All of these compounds are capable of hydrogen bonding except 1-butene. So hydrogen bonding increases the boiling point, and if you do not have hydrogen bonding, the boiling point will decrease. So only one option which seems suitable is 1-butene. 1-butene will have lower boiling point due to absence of hydrogen bonding. So option C will be the correct answer. Now come to question number 2. In question number 2, we have been asked predict the product of the following reaction, where we have been given benzyl alcohol PHCH2OH reacting with PCC. So PCC in the presence of methylene chloride. So this is your benzyl alcohol with PCC in the presence of CH2Cl2, which is acting as a solvent. We know PCC is a mild oxidizing agent and converts your respective alcohol to aldehyde or ketone depending upon the position of your alcohol. So this is on the benzylic position, or you can say 1 degree carbon, 1 degree but benzylic. Hence this CH2OH will convert into CHO. PCC is a mild oxidizing agent which oxidizes primary alcohol to aldehyde. So the answer here will be benzaldehyde, which is our option number C. Now come to the question number 3. Question number 3, give the expected product forming in the following reaction. We have been given carboxylic acid and ketonic linkage on the cyclohexane, and we have been given excess of methyl magnesium bromide, and we have to do the reaction. So this is the given reaction. Now first of all, understand methyl magnesium bromide is going to generate Me-, which can act as base as well as nucleophile. So first of all, it will figure out if there is any acidic hydrogen present, then this species will act like a base. Yes, we have an acidic hydrogen on the carboxylic acid, so that will go along with CH3. So CH3- is getting generated. It is taking the acidic hydrogen here, and MgBr plus is gonna form the bond with oxygen. So here this will form. Here the reaction will be MgBr with oxygen and CH4 will be getting released. This is because of the presence of acidic hydrogen. So basically acid base reaction is happening with the 1 first mole of methyl magnesium bromide. Then again the reaction will take place on this ketonic carbon and oxygen, and CH3- will attack on this carbon. There is a delta positive charge here, delta minus here. The bond will cleave and it will form CH3O MgBr. After this, when you will try to neutralize by adding water, all the positions where the negative charges are, basically wherever the MgBr is present, H plus from water will come. H plus from water will come and displace the MgBr here as well as here. So you'll get OH here and OH over here. So it will form 2 MgBrOH. So this is how the reaction is gonna be. So according to that, the answer is going to be answer B. This is our product B. Okay, option B. Come to the question number 4. In question number 4, we have been given a compound which is ester and ether both, cyclohexane with the ether and ester linkage, and we have been asked to reduce it using dibyl H. We have been asked what is the major product. So first of all, understand dibyl H reduces your ester linkage, so it will cleave the bond, this carbon oxygen bond, and will be giving H here as well as H here, ultimately forming aldehyde and alcohol. This we have learned when we had done this chapter. Dibyl H reaction with ester causes the preparation of aldehyde. This we had done in the preparation of aldehydes using the reduction process by dibyl H. So dibyl H will be adding hydrogen. So in the presence of dibyl H, H- will come and attack on this carbon and the other H. So basically it will be something like this: CO- H O, and this will form the bond back and this will be out. So you will get an aldehyde here first. After that you will have a CH3O-, which will get the H plus from the water, forming CH3OH. So this is how the dibyl H attack would be. So double H will generate H minus, water will generate H plus, and these will get attached on the respective positions. So first attack of H minus will happen on the carbonyl carbon. Then pretty much like SN2TH type reaction where O minus will form the bond back, leaving group will leave, and ultimately H plus it will get from the water. We'll get an aldehyde and alcohol. This is our option number B. It will definitely not affect the ether. Ether will not get affected by double H. Now let's talk about the question number 5. In question number 5, we have been asked double H can be used to carry out which of the following conversions. Just now we have done the question, and we have the aldehyde here where H minus is coming from double H and H plus is coming from water, and ultimately this carbon oxygen bond is cleaving. We are getting aldehyde and ROH same as the above. So double H is the one which is used for the conversion of ester to aldehyde. So this is your option number